In this video, we will build a POC of an IoT solution using ORDS API on Oracle Autonomous Database, iOS app with Objective-C, Python on Raspberry Pi. Yes, you got it right. We will not use any of the IoT Cloud Services available in the market to do this. So we'll start by creating a directory. So I'll name it sh. Now I'll change it to sh. In this directory, we are going to create a Python file named as sh-device. The extension we will use as p.py. So, first in this code, we'll get the data from ORDS REST API. For this, we will import certain predefined modules. So, I'll use import requests. Okay, so the Oracle ATP module is our own custom module which we have created. In this module, I have defined a dictionary type variable in which I have stored the base URL. Okay, so I will use base URL. I'll create a new variable named as base URL. We'll use atp.urls. This is our dictionary type variable, and we're going to use URL. Okay. Next, we are going to assign API endpoint and point URI. So I'll type in the URL. Okay, so now we are going to create custom headers. We are going to use the custom headers while creating a request. So we sh username. Okay, next we are going to create response. The response will submit the request with the get method. So we'll use requests.get. So we are going to concatenate the base URL with the API endpoint URI. And add the headers goes to custom headers. Next, we are going to get the JSON data from the response. So for that, we'll create JSON response and we'll assign it with response.json. Now, the response JSON has an attribute named switch with the value on off. So we are going to assign that value in switch value. So we'll use JSON response with switch. And next we are going to clear the screen. So we'll use OS system clear os.system clear, and we're going to print the switch value. Okay. I typed in the wrong spelling of switch. Okay. Okay. So now to compile and execute the code, I'll clear the screen. We'll use Python and our file name. Okay. Oh, I forgot to copy the module. So I'll use cp pyc, and we're going to use okay, so now let's check. So let's go back. Oh, I forgot to type in the brackets, the parenthesis. So now I will execute it. Python. Okay, so we have off. So now I'll change the data. So I'll open Postman and I'll change this to on. Now I'll submit it. Success. So now let's check this one. Okay, so we have on. Now you see that I have to always run it when I change the data. So for that we will use while loop. So for while loop we'll use while one infinite loop and the indent. And we'll also import time to use delay. So we'll use time dot sleep. We'll use 2 seconds. So now let's check it. Okay, now I'll change it to off. Submit it. Success. Now let's go back here. Okay, so it's switched off. The value's off. I'll change it back to on. I'll submit it. Okay, now it's changed to on. Okay, now I'll change it to off and click send. Now see, it's back to off. Okay. Okay. So now we are going to connect an LED to our Raspberry Pi. We are going to switch on and off the LED depending on this value. So that means that we are going to switch on and off an LED from Postman. So now I'll exit the program. Okay. Now I will type the code to switch on and off the LED. So I'll go back. I'm going to first import from GPIO0 LED, and we're going to create LED, and we are going to use 17, which is our pin number, in which we are going to connect our LED. So next we are going to type in an if condition to check whether the switch value is off or on. So if switch value is equal to off, then we will LED.off, and if it's not, then we'll switch on the LED. Okay, so now let's build a circuit, and instead of the sleep here, we'll paste it here. Okay, now let's build our circuit. So now we are going to connect our LED to the Raspberry Pi. So before we can start, we'll see the map of the pins of the Raspberry Pi. So I will use pinout command. Okay, so this is the pin map of the Raspberry Pi. We are going to connect the positive pin of the LED to GPIO17, the 11th pin, and ground to ground, the 6th pin. Okay, so first we'll connect the LED's positive pin to the Raspberry Pi. So the pins is like 1, 2, 3, 4, 5, 6. So 1, 3, 5, 7, 9, and 11. So this is the 11th pin. So I'll take so I'll connect the wire here, and I'll connect it to a breadboard. And the ground is in the 6th pin, so it is 2, 4, 2, 4, and 6. So connect it here, and I'll connect this to the negative rail. And the LED. Okay. So now let's check whether the code is working fine. So now I'll execute the code, use Python and our file name. Okay, so it's off now. Now I'll change it to on. Okay, so it's the LED switched on. Now I'll switch it back to off. Okay, now it's switched off. So our code is working fine. I'll change it back to on. Okay, it's switched on. Now back to off. Okay, now it's switched off. Now we are going to make this video more interesting. Instead of using Postman to switch on and off the LED, we are going to build an iOS app to switch on and off the LED. So now I'll create a new Xcode project. Okay, so I'll click iOS and then app. I'll select the language as Objective-C and I'll name it as Smart Home POC. I'll save it in my desktop. So it's created. Okay, so first I'll just disable this. Go to the main storyboard and change properties of this view controller. I'll change the background color to black and I'll drag in a switch. Place it here. Label change its color to white. And an image view. I'll change its auto resizing. And I'll change this image, the image views image, to bulb. And I'll change it to a color. Okay, now let's start with our code. So first I'll drag the objects for the image view, the switch, and the switch. So I'll name it as bulb image bulb preview, and the switch and an action switch. So first we are going to get data to check if the light is already switched on or off. So name it as get state. So first NS URL session configuration. Default and NS URL session. I'm going to assign this with NS URL session with configuration, user configuration, delegate and delegate queue. Delegate will use self. And delegate queue to nil. Next, we'll create a string full URL and a string with format. Okay, so I'll just open this. I've created two files, a class. So in this I have defined the base URL, so I'll copy it and I'll drag it in our project. So now I'll import my utilities. So I'll use %at, and for the get, the URL I have is this. Paste it here. And I'll use base URL, which is inside the class. So next we're going to create an SURL equals to URL with string. And our full URL. Okay, so next we are going to create an mutable request, URL request, then request with URL with request. Request with URL, then we'll use URL. Cache policy, we'll use NS URL cache. Yeah, NS URL protocol cache policy, timeout interval 60. Next, we are going to create add headers. So I'll use request, add value for HTTP field. So I'll use user1, and for HTTP field the sh username. And next we are going to set the HTTP method to get. And get. Okay, next we'll create an session data task, and data task equals to session data task with request completion handler. So we'll use our request, and we have to create a block. Inside this, we'll create an data, an URL response, and then NS error. Okay. Oh, I have used an state. Okay. So inside this, we'll create an dictionary JSON. We're going to use JSON with JSON serialization, JSON object with data or data, option 0 and error. And next we're going to assign this in an array. So I'll name it as items. Use JSON items. Okay, so now we don't need any for loop in this because we have only one data coming in the JSON response. So will you create a string, name it as state. Nope, I've also forgot the semicolon. Okay, so we are going to use state equals to items switch. Okay. We don't need an array. We can use JSON instead. Okay. So now in the view.load, we'll call our getState. Then we are going to assign state, check if state is equal to off. Then we'll use our switch set on equals to true, and else means if it's on. Copy this, paste it here, and instead of true I have to use false. I'll also print it. We'll use printf nslog. And state %at state. So now let's check it. So I used like this. Let's change it like this is equal to the string. Okay, now let's test it. Okay, so it's building. Okay, so it's okay, so we have the app loaded. State null. Oh, I forgot to resume the data task. So data task resume, and I'll also give a delay of 2 seconds. Sleep until time interval. Oh, it's 2.0, 2 seconds, and I'll use the image view which we have created, bulb preview dot tint color equals to UI color dot yellow color. and if it's not, we'll use the default color. Light gray color. So I'll upload it. Okay, so it's uploading. Oh, so it's off. Light gray color and yellow color. Okay, so now let's create another function. So it's set off. Let's create another function that set state. So in this we are going to pass a parameter in a string state. Switch state, I'll name it switch state. Okay, so I'll copy the whole get instead. I'll change this to post. And I have a separate URL for this endpoint URI. So I'll copy this one. Okay, so I have to add the header fields. This one will be content type except, and these will be application/JSON. Okay, now let's create an dictionary named as map data, and we're going to assign this with an dictionary alloc init with object and keys. And we are going to first use our switch state and switch, which is our key name. Next we'll create an data and I use date. I'll name it to post data, and we'll assign this with NSJSON serialization data with JSON object. We'll use our map data options 0 and error. I'll create post error. So NS error post error. Okay, now we'll save use request set HTTP body, and we'll use post data. Okay, so in the switch function here, a trigger, we check if switch is on, then we will call our switch set state self set state, and we are going to use on. And if it's not, means we turn it off, we are going to set it to off, and we are going to copy these lines. So if it's off, then with that, and if it's not off, not switched off, then yellow color. Okay, So the Python program which we have typed in the Raspberry Pi is running. So I will stop it and okay, and now I will upload it. Okay, so now as you see, the LED is switched off, the bulb and the switch is also in the switch off state. So now I'll switch it on and it's switched on. Now I'll switch it back off and it's switched off. Okay, I'll switch it back on and it's switched on. I'll switch it off and the LED is switched off. Okay, so that means that our app is working fine. You can extend this solution to control your devices and appliances at your home or office from web, mobile or desktop, and also add different sensors to build different automated and intelligent solutions. Thank you for watching.